Right, so my name is Tutor Marius, and I'll be taking you in the course MTM101, which is mathematics for the first semester. And we're going to begin from here. And the first topic we're looking at is sets. So feel free to ask whenever I have a question, just you can speak, then I'll respond to you. So now, we're going to start from here. What is a set? So we have this definition here, and it says that a set is a well-defined collection of distinct objects. These objects are called elements. So we're saying a set is a well-defined. So it has to be what? Well-defined. Key terms here that we must note: well-defined collection of distinct objects, and these objects are called elements or members. So we call them elements or members of that set. So the order in which the elements are listed does not matter, and an element can only appear once. So that element has to only appear once. So now, so when we talk of what a set is, we're saying it has to be well-defined, must be a well-defined collection of distinctive versus objects, which we are calling those objects, or we are calling them what? Elements or members of what? Of that set. So by distinctive, meaning that that element or that member can only appear what? Can only appear once. So for example here, so I have a set of even numbers less than 10. So the set of even numbers less than 10 is just, so the set of this the set of so I'm saying the set of distinctive objects like this one we have is saying the set of even numbers less than 10. So the set of even numbers less than 10, meaning 10 is not part of it, because we're just saying numbers that are strictly less than what? Less than 10. Then if you are to list down those numbers less than 10 and even numbers, so by definition an even number is just a number that is divisible by what? By 2. So you know that those numbers that are divisible by 2 that are less than 10, you have itself starting 2, 4, 6, and what? And 8. So now we see that this is a well-defined versus collection of what? Of objects. Why is it well-defined? Because it said even numbers. So I know what type of numbers are what? Are in this set. Then we see that there these same elements or members that are here do not what? Do not repeat. 2 is only listed once, 4 is only listed once, 6 is only what? Listed once, and 8 is only what? Listed once. So this here becomes what? A well-defined collection of what? Of those elements. And of course, we are calling them what? We are calling them these objects, which we are calling what? We are calling elements or members. Then we see that on the second part, we have this example to say that the set of what? Of vowels in English alphabet. So the English alphabet has these vowels, which is R, A, E, O, U. So these are what? Are the distinctive objects or elements that are what? That are in this set. So you have your R, A, E, and what? You have your A, E, I, and O, and U there. So these make up what? The set of vowels. And here you are able to know that this, okay, is what? Is a set of vowels, because you know what the vowels are, and the way it's been listed, it tells you that these are a set of vowels in the English alphabet. So it's stated clearly here. That's why we're saying it has to be well defined. So well defined, take note of this. Well defined is very important. That's why they're saying vowels in the English what? Alphabet. Because somebody, if you keep it open as vowels, they can be vowels in the what? Maybe in the Greek alphabet, it's going to be different. You talk of the Chinese alphabet, it's going to be what? To be different. So, for example, another example I would give is maybe you're talking of a set that contains, let's say, that contains short people. So now, if you keep it like that, well, that would not qualify, in fact, to be what? To be a set. So the statement, let me write the statement. The statement is uh, set of short people. Short people. So this here does not qualify to be what? To be a set. The reason why it does not qualify to be a set is you do not know, okay, what what criteria are you using to identify the short people? So what would be best is you maybe to say a set of short people that is anyone less than anyone less than 1.6 watt meters, then this will be classified to be short. So you can be able to collect this information now in your set. So sets have to be well defined, and whatever is in the set, we are calling we are calling members or or elements. Okay, so if there are any questions, as I said, you are free to ask. So now we are going to go to the next segment where we're saying representation of of a set. So now, as you've observed that the set itself, we are denoting the set by a capital letter. So a set in this course is going to be denoted by a capital letter. If we talk of a capital letter, we're talking of a set. Then, if we're talking of members or elements, we are going to denote using small letters. That's the reason why we said, for example, let me list from A, B, and C. So when I'm listing elements in my set, they're going to I'm going to use lowercase letters or small letters. That's how I'm going to denote them. Then another thing to observe is that these things here, which we are calling braces, these my braces here, they are written like this, like that. These will be used inside here in able to for us to list out our elements. So in some cases, as you will see, we will be using We'll be using brackets like this, or we'll use square brackets like that. So it will depend. So mostly we use the square brackets and the brackets when we're dealing with an interval form. For example, where I'm saying that I am running, if I'm on a number line, then so a number line, and you are saying, I want to list down, for example, the set of natural numbers. So set of natural numbers, these are numbers that you just use to count. So, and they're denoted by n like this. Numbers used to count, and these start from 1 going to infinity. So 1, 2, 3, 4, up to positive infinity like that. And so you cannot, listing them would be a lot. So what you would do is, if you would use something like where we say 1, then comma, infinity, and it's open at infinity. So now closed, this square bracket is going to represent that it's closed, meaning that 1 is part of Part of that set. That 1 is part of that set. And on the other side, where it is open, you're using a bracket that is open like this, would mean that infinity is not part of it, because you don't know what positive infinity is. It's not a specific value, so it cannot be part of what is said. So you use it in terms like this. But for now, let's say consider where we just have these braces, which are what we are using like that. Okay, so this is what we are going to denote. So if, for example, let's bring back what we said. We said A, there's A, B, and C. So we will denote, so we will use this symbol here to mean a member of. So for example, here I can say that A is a member of what? Of the set A. Then we will use this symbol to mean not a member of. For example, Z is not a member of what? Of A, like this. So that's how we are going to to work out using this. So I think you remember this from your basic O-level math. Right. So now let's understand this. So there's a representation of a set, and there are two main ways in which you can represent a set. Number one, we're calling the roster method or the tabular method. So the roster method or the tabular method is just a method where you're going to be listing out those elements. So you're just listing out to say, okay, this is my uh, you list out whatever is in the set. I think the example I've been giving is in tabular form or roster form. So you have A, you have B, you have C, like that, listed out like that. So this here is how you would represent one of those sets. And we're saying that this here is the tabular form or the roster form. And we have these examples here. So now I want you to list them out with me. So it's saying write the following in roster form. And you have A, they're saying, so, okay, what has been written here is another form actually. This form, which we'll look at in a bit, which is the set builder notation, if you remember. So it's saying A is equal to the set of OX such that X is a member of the natural numbers and X is in between. This is what 50 and 60. But you see there's a less than or what or equal to where there's 50 this side at the left here. There's a less than or equal to, which means that that 50 has to be part of what? Has to be part of those natural numbers which we're listing. So now let us list out this set in what? In this roster form. Okay, so what are the numbers that are going to be involved? Okay, if you're able to get me, what numbers are we going to involve? Okay, if you can't see, let me write the set here in case you can't see it. So it's saying A is equal to X such that X is a member of the natural numbers, and we're saying that this X is in between what? 50. Here it's less than or equal to X there, then 60. Okay, so now let us list down. We're saying we're looking at the tabular or roster form. Yes, so what are the numbers that are being involved here according to set A? So what I said is if you want to answer, just speak. Yeah, just speak. We'll get you, then we'll be able to assist to respond. Anyone? Okay, so there's no one, but we'll list.
I have a question.
Yes.
No. I have a question.
Yes, you can ask.
When you're listing the natural numbers, they have to be between 50 and 60.
Yes.
Or I just list the normal natural numbers.
Okay, so in this case, because they're telling us there's a condition of X being a natural numbers and is in between. So it's here, so you have to list the numbers in between here. But remember, there's a less than or equal to sign where there's 50. So which implies that what? 50 is also part of what? Part of the listing here.
Yes.
Okay, yeah. So that's what.
Then that means that the natural numbers should be 51 to 59.
Okay, so 51 to 59. But then remember there's a less than or equal to sign where there's 50. So meaning we're starting at 50 itself. So 50.
Oh, and then ending at 60.
No. Ending at 59. You're right. Ending at 59. Because here, look at this side, there's no equal to sign. It's just less than, strictly less than 60. So we go from 50 to 59. Okay. So we have 51 here, 52. Then you're going to have 53, 54, 55. Then you have 56, 57, 58, then 59. Because here it's strictly less than and there's no equal to sign. That's the reason why we want to list it like that. Okay, are we all together here? All right, so this is what we do. Now, let us then work out the second part. So we've listed out. This is the roster form or the tabular form, which we are talking of here. Okay, so now the next one is you have this here B, and B states that X is a set of OX. I mean B is a set of OX such that X is a real number, and this real number X is found using this equation here. So this equation is just X squared minus 5X. Then you have plus 6 and equal to what? To 0. So now let us work out this. So working out, this is a quadratic equation. So a quadratic equation meaning you can find the values of what? Values of X. So let us first use the product factor rule. So we're going to say the product here, product is just A by C. And our A, if you can see here, that is 1. And then your C is 6. So you have product is going to be 6. Your sum is just what is in between here, which is -5. Then you have your factors now. So factors is when we add, we should get negative what? 5. But when we multiply, we must get what? We must get 6. So what two values are those? What two values are those? Okay, what two values are those? All right, so those two values, we have negative what? We have negative 3 and negative 2. When I multiply these, I get the positive 6. I add them, I just get negative 5. So I can now replace them here like this. Then I have there, let me put my negative 2x. Then I put my negative what? 3x, then plus 6 equal to what? To 0. So this factors with that, and this then also factors with that. Okay, so here I can factor out an x. It's common in both of them. Have x, then I have x minus 2. There, I can then factor out what? I can then factor out, let me factor out, okay, so factor out a negative 3, such that here I'll remain with what? I will remain with my, this here remains with x. Then here, when I divide into that there, I will remain with what? Negative 2. So this here then, all equal to what? To 0. So you see that this part and this part are the same. Then I can just write one of them, which is x minus 2. Then I have x minus what? Minus 3. So x minus 3, and all this is equal to 0. So this here equating means this equal to 0 and that equal to 0. So I have x minus 2 equal to 0, and I have x minus 3 equal to 0. So here you're going to have x equal to 2, then you have x equal to what? To 3. So those there are going to be the what? The values which we get. So these here are the values which we are saying, or these are the members that are in that what? In that set. So this is 2. In members of what? Of that set B. Since B was defined as x, such that x is a member of the real number and is defined by this. So I write it now in the roster form. So this is going to be B equal to, then I list down those elements, which is 2, 3, like that, and this here is my set. Okay, unless there's any question on the tabular form and how we do it. Okay, since there's no question, we move. So the next part, of course, is set bidder what? Set bidder notation. I think of which we have seen it even in the previous part where we're doing. So this here is an example of what? Of a set which is in set bidder notation. And we break down what this means. So the first part here, of course, we know this is the set itself. So this is the set A. You have your equal sign, you have your what? Your brace, since we said that we use these braces to denote our sets. Then we're saying X. So X is just representing an element in that set. So this element is, I mean, this set is a set that involves the elements of what? Of X. So that's the reason why you have X there and you have such that. Then these dots, two dots here represent or mean such that in other books you see they'll just write a dash. So it will be something like braces, you have X and you have your dash. This is going to mean such that also. Then you're saying your X is a what? Is a member of the natural numbers. So this same X we're saying, so this the set A has elements X, which is just an arbitrary element. For example, it's not listed out, but you know it by the what definition given here. So you have X, a member of the natural numbers. So it's a natural number, and it is what? It is X is such that it's less than what? Less than 7. So natural numbers that are less than what? Less than 7. So, and if we're to go back just to apply the knowledge we've gotten on the tabular form or on the roster form, what will this set contain? Yes, anyone? What will this set contain? Let's list out this set. Hello.
First, can you go through the set bidder notation again?
Okay, so again, I say this here, we have a set.
Yes.
So the first part represents the set itself. So A is the set. You have the equal sign and the braces here. We said if we want to list down our set, we'll be using the braces there. Or we'll use, in other cases, we use brackets or square brackets. The first part we're saying it's a set of X. So X is just any element, in short, any element. So now what follows next here, you're saying, okay, this any element. Now let's specify it. That's why they such that then you're saying your X is a what? Is a member of the natural numbers. So this is the specification. It has to be a natural number. X is a natural number. And apart from it being a natural number, X has to be what? Less than 7. So in short now, what I'm saying is from the knowledge we've gotten on roster form or on the tabular form, which is just listing out your elements, what is going to be contained in this set. So I'm saying let's list out now the elements of this set. So we're saying that it's a natural number and it's less than 7. So in short, list down the natural numbers that are less than 7, which are, now you can proceed.
Okay, then that should be 1 to 6. I'm
Okay.
correct.
Yeah, so 1 to 6, as you've said, 1, 2, 3, 4, 5, 6. So these here are going to be what? Yeah, that is your set A in tabular what? In tabular form. Now, let us look at this example. So we are now the example, we are moving now from the roster form or tabular form, we have to write it into set Peter notation. You have to write it into set Peter notation. So let's start with the first one, A. How is this going to be? Uh-huh.
Let's see.
Uh-huh. Let's go. Okay, so I start for you saying A is equal to your braces. You're saying the same thing, X such that. Then you are saying X such that here, X is what? So look at these numbers here. What are these numbers here that are listed out?
These are all positive and negative numbers.
Yes, they are positive and negative numbers, which are just integers, right?
Yes.
Yes, so meaning X is an
So
is an
it
integer.
should be X integer.
Yes, which is so X a member of
So
like this, eh? Uh-huh.
oh,
So integers, remember the Z, this Z represents integers, set of integers. Then we are saying that, so it's a member of the integers and it's in between what? So if you are to look at this, so you would write and or write a comma.
in between 3 and 3.
Yeah, so negative, -3. So less than or equal to, because
And
I can
positive
see
3.
that. And then also the other side, 3 like this. So this here is my set builder. Say, I mean my set in set builder notation. Okay, I hope that's clear for everyone. Now let's
Mhm.
go to the other one, which is B. So what is B now? How are we going to write B?
So these
Mm.
are X such that X is equals to think primary. I think this should be primary numbers or something like that.
Okay, no, not exactly. Because you see, there's 3. Okay, so you can observe there's 3, there's 6, there's 9, there's 12. So one thing you observe that these are all multiples of what is? They're just multiples of what? Of 3.
3.
Yes, so they are multiples of 3. So meaning how are they being found? So x is just equals to, this one is what is 3n, right? 3n, because you see
Yes.
whatever n I put here is what I'll be getting. So 3n,
I think
then
they're like
I
that's
can
too bright.
specify to say that
Okay.
my n, which is just going to be what? A member of the natural numbers. N is a natural number like this. And of course, what other condition does my n have? My n is what? My n is going to be, I have 4 numbers here. There's 1, 2, 3, 4. So meaning my n a natural number, and n has to be less than or equal to 4, like that. So this is how I write it. Okay, do you have any questions?
So you don't need, you just need to know the number of elements in the set. You don't tell by the
Okay, so like for in this case, yes, you needed to know, okay, there are 4, because these are not, say, per se, a group of numbers. They are not they are not, what can I say? They are not even numbers, or per se they are prime number, so we can't just what's this. So here you can see there's this pattern that is going about, that oh, they are all multiples of what? Of 3. So x is a multiple of 3. So that's why we wrote this here. It's a 3n, because I know for whatever n I put here, starting from 1 to 4, I'll get this set. And that's the reason why I said the n is a natural number, because we know that natural numbers start from 1 going to infinity. But now I'm just picking a section of it, which is just from 1, from n to what? To 4, from 1, I mean, to 4. And that's why we're saying n here has to be less than or what? Or equal to 4. But for the fact that I've already stated that n is what? Is a member of the natural numbers, it means that I know that where I'm ending with my n is actually 1. I'm not going anywhere below what? Below 1, because we're talking of natural numbers. Yeah, so that's how you identify it in this case.
Okay.
All right. So if there's no further questions, then we move on to looking at these definitions before we come to the close of our today's lesson. But yeah, so let's define this here. So there's what we're saying, a singleton set. So a singleton set, or 1-point set, is, or unit set in what, in other terms, is a set with only one element. So for example, A contains only what? A single element, like that one. A contains only one A, then it's called a singleton set. Then the other definition is when we're looking at an empty set. So an empty set is an empty set, also known as the null set. The null set, or the what? The void set, is a set which has no elements in what? In it. And we will denote it by what? Just open braces like this, or the what? This Greek symbol like this. So this here is going to what? To mean empty. So if I write this or write that, then what we mean is we're talking of an empty set there. Okay, so this is what we would denote. So singleton only has one element. Empty set has no element in it. All right, so in fact, all right, so let's look at now this part of this of what was this. But before we look at this, let's get back a bit here, and I want to list down something. So another thing is, for example, if I have 1, 2, 3, 4 like this, then there's another term which we have to know, which is cardinality. Cardinality. So cardinality of a set is how many elements are in that set, is what is the cardinality of what? Of a set. So when you look at this, how many elements are there? There are just 4 elements. So the cardinality is what? Is 4. So the number of elements in a set is the cardinality of what? Of that set. Okay. Then we move on to what we call the subsets. Yeah, so a subset, so we're saying suppose you have A and B, be any what? Be any 2 sets. So A and B be any 2 sets. Then a subset of A. So A is going to be a subset, for example, of B, if every element of A is also a what? Is also an element of what? Of B. Then symbolically we denote it as what? As A being a subset of what? Of B. So this symbol here in between means what? Means subset. So if every element of what? If every element of A is contained in what? In B, or is an element in B, then we are saying that A is actually a subset of what? Of B. In short, A can be contained in what? In B. Okay, so we have examples here. For example, here you have this set. The set A is 2, 4, 6. 2, 4, 6. Then we're saying that B is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That is B. So now we can see here that since each member of what? Of A belongs to what? To B. So 1, 2, 6, this 2, 4, 6, they belong to B. It's here. You can see that there's 2 here, there's 4 there, and there's 6 there. So because this happens, so we're saying that A is going to be what? A subset of B. Means A can be contained in what? In B. And later on, when we start looking at Venn diagrams, you see that we usually denote that to say, okay, B is the outside set, then A is going to be contained like that. It means the elements, these 2, 4, 6 can be put in here. 2, 4, 6 can be put in there. Then the other ones, which is 1, 1, 3, 1, 3, 5 can be put what? Can be put outside like that. Then this is the whole set outside, including this is going to be B. But this set contained here is what we're calling to be what? To be our A. So if that is true, then this will hold. All right. Then now the second part of it, our second example, we see that they have a set which is 1, 3, 5. And we look at the other set, which is B. It's 1, 2, 3, 4. 1, 2, 3, 4. So now here we're saying since A, look at here, since 5, this 5 is not in B. So 5 is a member of A, of course, 5 is a member of A, but this 5 is not in B. So it means that A cannot be a subset of what? Of B. So meaning like all elements that are in A must be in what? In B. Then we will say that what? A is a subset of what? Is a subset of B. But if there's an element like here, there's 5, 5 is not in B. So this A cannot be a, what? A subset of the set B. Okay, I don't know if you have any questions on that one. Okay, so I think that's clear. Then we just look at again. So there's what you call a proper subset. So a proper subset is so for example, the way we said that for A to be contained in B, it means that all elements that are in A must be in B. Then if we're not sure if all the elements of B are contained also in what? In A, then we say that A is a proper subset of what? Of B. So if we're not sure if all elements that are in B are also contained in A, then we say that B is a what? Is a proper subset of what? I mean, A is a proper subset of B. So that's the term proper subset. Okay. Another thing that we'll look at is two sets. So two sets are said to be equal. So A is said to be equal to the set B if every element in A is also in B. So if I have a set A and it's listed A, B, C, it means that the set B also has to be what? Be listed to be what? To be A, B, and what? And C. They must have the same elements. Of course, the order of how I've listed them might change. Like it might be maybe it's listed as C, B, and A. These are the same. So because they have the same what elements, they have the same number of elements and they have the same what elements, then these will be said to be what? To be equal sets. So these will be said to be equal sets. Apart from this, you can show that the set A is equal to B. If A is contained in B, that is A is a subset of B. It means every element in A is in B, and if and only if what the set B is also contained in A. So meaning every element of what? Of B is also contained in A. Then we would say this would mean that the set are what? The sets are equal, meaning A is equal to what? To B. If A is a subset of B and B is a subset of A, then we say that A is equal to what? To B. So this here is how we would define what a subset, or when sets are said to be what? Said to be equal. All right, so this was a basic introduction which we just had on set theory and looking at the definitions of sets. So in the next class, we are going to cover set operations and how we work out with what these sets, how do we put them to play, how do we now practice these sets. Okay, so I don't know if there's any question from anyone, but this is where we end with our class today. Is there any question? Okay, there's no question. So remember that consultations you guys can consult. You've seen my number in the group. You can text me and inquire for anything. Then we shall continue with the free classes this week and next week. And as the message says, after the 2 weeks, then you have to pay the 150 and you can subscribe the on the website. So the website link I think has been shared. You can subscribe on that website, and also I think after 2 weeks you'll be able to download the mobile app where you can watch. You can be able to subscribe or to check out everything, our videos and other content that we offer.